Hi, and welcome to this introductory video on the normal distribution, which is in the Year 2 stat part of the course. There's two distributions, or two probability distributions you need to know about. The first is the binomial. You would have done that last year, Year 1. In Year 2, the one that we're looking at is the normal distribution. So, quite a lot to get through, but this video is just going to have a look at that first bullet point, just have a look at what the normal distribution is and look at the characteristics of the normal distribution. And then in next videos, then we'll start looking at how we deal with probabilities and stuff using the normal distribution. So here we go. So what we've got there is a histogram showing the heights of 150 18-year-old students. And you can see it's got the following characteristics. So we've got the modal class in the middle. What we've got is it's symmetrical, and the frequency density falls off rapidly as you move away. So basically what we're saying is for people who are measuring heights, most people will be kind of, if you want to call it average heights around the middle here. You get far few people that are very, very tall at this end or very short down this end. So what you get is this kind of shape with most people in the middle, and it falls away to either end. And what you've got, because it's symmetrical, you've got a characteristic that the mean and the mode and the median will all be right down here. So they've all got the same value for this particular distribution. Now, that shape of distribution is very common for a whole range of different things. So that idea that most things are in the middle and then there's far fewer towards the end of the range is like I say, a very common distribution. That's what we're going to be looking at. Now, if we add on the frequency polygon, so just put that, which is essentially the line that just joins the top of the bars. And now let's get rid of the bars, and there you go, you've got this, well, that's kind of pointy, but it just shows us the shape of the distribution. Right, so let's go on a little bit more, but let's take exactly the same data, but this time we're going to draw a histogram, but we're going to reduce the class width, so we've got narrower bars. And so what you've got now is there's the same data, narrower bars, we've got the frequency polygon already drawn on, and straight away you can already see that the frequency polygon fits a lot better to the bars. There are still little bits of gaps, but essentially, let's say it's matching much closer to the bars now than the previous one. If we keep going with that, if we keep making these bars narrower and narrower and narrower, what you end up with is a frequency polygon that looks like that, and it stops being kind of pointy and angular and becomes a curve. And that thing there is what we can refer to as a bell-shaped curve, and that is what a normal distribution looks like. So let's say we start off with a histogram, and by narrowing the width of bars, we end up with this nice distribution here. So there's our normal distribution. There's our curve for 18-year-olds. If we now take some more data, we're going to put some data over the top of that, and let's say we're looking at the heights of 11-year-olds, and it might be we get a curve looking like that. You think, well, what's going on? Why would that curve, that blue curve, be different to the purple curve? Well, essentially what we've got is the mean is much lower, obviously because 11-year-olds are smaller than 18-year-olds because they're not grown yet, and also you've got less of a spread. Because obviously with 11-year-olds, with 18-year-olds, as they grow, some will grow faster, some will not, and you get a much wider spread of heights for 18-year-olds than you would with 11-year-olds. So what we've got essentially is the same shape of curve, but we've got two distinct differences. We've got the mean in a different place, and we've got a different level of spread. And so what it's telling us that we're controlling the normal distribution by two parameters, two values. The first of these is the mean, and for the normal we use the letter mu to indicate the mean, and the second one is the standard deviation. So those two things are going to essentially determine where our normal distribution curve is going to be for any given set of data. If we're going to describe any particular distribution, what we do is say we have our continuous random variable, x, continuous being that the random variable can take absolutely any data at all. That's different to the binomial last year when the binomial distribution is discrete, the normal distribution is continuous. So we've got the continuous random variable is normally distributed, so that squiggle in the end means it's a normal distribution with a mean of mu and a variance. Now, watch out for that one because when you're describing it, the convention is to use the variance, but the value you'll be working with is the standard deviation, which is the square root of the variance. So you'll see what I mean about that one a bit later on, but I'm just flagging that up now as something to be aware of. Okay, let's go back to our original data set. And so there's our 150 18-year-olds. And we can use the histogram to calculate probabilities. So let's have a look and see if we can find the probability that student selected is less than 170 centimetres tall or less than 190 centimetres tall. Let's start off with the 170. The number of students less than 170, on a histogram, the frequency is the area of the bars. So let's identify the area, there it is in yellow. And if we worked out the area of each of those bars, we end up with 124 students. So the probability that we've got a student that's less than 170 centimetres tall is simply 124 over 150, which gives us that value there. If we wanted less than 190, that one's very straightforward, and the reason I'm using this is just to indicate that we've got the entire area of all the bars there, all less than 190, so the probability of having somebody less than 190 is just 1. If we take exactly the same way and did that using a normal distribution curve, so there's our normal distribution curve for this data, and so if we said less than 170, there it is. And so what we've got now is the area under the curve is that 0.8267. Right? So what we're saying is the probability is given by the area under a normal distribution curve. Key thing is it's the area, in this particular case, it's the area to the left of our 170. And the other thing, the point I want to make is the less than 190, clearly the complete area under the curve is going to be an area of 1. Right. So, just to summarise all of that, so what's going on with the normal distribution, and what we've got is it's distributed with our parameters mu and sigma, and it's the variance sigma squared is the one we use to define it. Mean equals mode equals median, it's symmetrical about mu. The area under the curve is 1, as I said on the previous slide. Now, here's some facts that you do need to be aware of. On the new spec, they do like to check that you've got an understanding of what's going on here. Now, what we've got is approximately 68% of the data lies within one standard deviation of the mean. So if you had a much wider standard deviation, give you a flatter curve, it wouldn't matter. You'd still have 68% of the data in that central part, which is plus or minus 1 standard deviation. So basically, if I take the mean, add on the standard deviation, that's this value. Take off the standard deviation, that's this one here. 68% of the data approximately is within that. Approximately 95% of the data lies within 2 standard deviations, and 99.7% of the data will lie within 3 standard deviations. That means those are figures that you are expected to be aware of. It might be you get a question that kind of tests your understanding of that. I saw one recently, I think it was on an OCR paper, that was asking you to make estimates based on these figures here. Okay, now, final point to make is that it says 99.7% lies within 3 standard deviations. Because you can get outliers, because you'll like to get people that are kind of, if we think about height data, either very, very short down this end, very, very tall basketball players up this end. That's why it's 99.7% within 3 standard deviations of the mean. Now, formula for the standard deviation. If we're going to start working out probabilities, we're going to need to work out, deal with areas under the curve. So you might be thinking, okay, integration. I don't know if that's if that thought occurred to you or not. But the formula for the normal distribution is that. Oh my life, what an absolute shocker that is. Do not worry, you're not going to have to integrate that thing. What we're going to do is get all the values that we need from our calculator. It used to be you had to look them up in tables, but now on the calculators for the new specs, you've got them all in your calculator. It's just a case of typing the right things there. And like I said, we will have a look at that in the next video. Cool.